morning everyone. I am Tanushri from Civil Engineering branch. In the last class, we derived the equation of torsion, that is T by J is equal to tau by R is equal to G theta by N. And today we will solve some numericals based on torsion equation. So here is your question, that is a shaft 50 mm diameter and 0.7 meter long is subjected to a torque of 1200 Newton meter. Calculate the shear stress and the angle of twist. Take G is equal to 90 GPa. So here basically you have to calculate the shear stress value, that is the value of tau, and the angle of twist, that is theta. So these two things you have to calculate from this data. So first of all, in the solution part, you have to write down what are the data given. So first of all, diameter of the shaft is given, that is 50 mm, and we convert it into in meter, that is 0.05 meter. Next is the length of the shaft is given, which is 0.7 meter. Then the torque value is given, that is the value of T, which is 1200 Newton meter. And last, G value is given, that is 90 into 10 to the power 9 Pascal. So 1 GPa is equal to 10 to the power 9 Pascal. So here we convert the value of 90 GPa into PA. So first of all, we need to calculate the polar moment of inertia. So as we know that here only diameter is given, so we can say this is a case of solid circular shaft. So in case of solid circular shaft, in terms of diameter, the value of polar moment of inertia is equal to pi d4 divided by 32. So diameter is given, so we can put 0.05, that is in terms of meter, we can put the diameter here. So pi into 0.05 to the power 4 divided by 32. Hence, the answer is coming as 613.59 into 10 to the power minus 9 meter to the power 4. So polar moment of inertia we have calculated here. Now, from the equation of torsion, we can find out the shear stress value of the shaft. So we know that the torsion equation as tau by R is equal to T by J. Hence, tau is equal to TR divided by J. So T is given, R is given, J we have calculated. So now we can put all this value here, that is 1200 into radius value is half of the diameter, that is 0.05 divided by 2. Hence the answer is coming as 0.025 divided by J value, that is 613.59 into 10 to the power 9. Hence the tau max value is coming as 48.89 into 10 to the power 6 Pascal. So by converting it into megapascal, the value is 48.89 megapascal. Now we can calculate the theta value from the second half of the equation. So we know that the torsion equation is tau by R is equal to G theta by L. Hence, theta is equal to tau L divided by GR. So tau we got the value as 48.89 into 10 to the power 6. L value is given in the question, that is 0.7 meter. Modulus of rigidity is given as 90 into 10 to the power 9 Pascal, and radius of the shaft is given as 0.025. Hence, the value of theta is coming as 0.0152 radian. So always remember, the value of theta for the equation is coming out as in the terms of radian. Then we have to convert the theta value into degree. So previously we know that 1 radian is equal to 180 by pi degree. Hence 0.0152 radian is equal to 0.0152 into 180 by pi degree. Hence by solving this, we got the value of theta in terms of degree as 0.871 degree. So we got the value of shear stress, and now we got the value of degree also. We got the value of twisting angle value. So now this problem is solved. So another problem we have to solve. So this is the next question, which is the second half of the first question, and here the internal diameter is given as 30 mm, and all those data are same as in question number 1. So only internal diameter is given as 30 mm. That means in question number 2, the shaft is the type of hollow circular shaft. So now for the hollow circular shaft, first of all, we can find out the polar moment of inertia. So as we know that for the hollow circular shaft, the polar moment of inertia value is in terms of diameter pi into capital D fourth, that is the diameter of the outer circular section, minus small d fourth, that is the diameter of the inner circular section, divided by 32. Hence, the capital D is the value of 50 mm, that is already mentioned in the question number 1, and small d, which is mentioned in the question number 2, that means 30 mm. So by converting 30 mm into meter, we got the value as 0.03. So hence by putting all these values, we got the polar moment of inertia value as 534.07 into 10 to the power minus 9 meter to the power 4. And now we can find out the shear stress value, that is tau max, by putting the value of equation of torsion, that is tau by r is equal to T by J. Hence tau is equal to TR divided by J. So T is given 1200, that is already mentioned in this question number 1. Next is radius, that is the radius of the outer diameter, so which is 0.025, and J value is 534.07 into 10 to the power minus 9. So by putting all these things, we got the value of tau as 56.17 into 10 to the power 6 Pascal, or 56.17 megapascal. So now we can find out the value of theta. So we know that according to the equation of torsion, tau by r is equal to g theta by L. Hence, we can put theta is equal to tau L divided by gr. So tau we got 56.17 into 10 to the power 6. L is given as 0.7 in the question number 1. Capital G value is given in the question as 90 into 10 to the power 9. and radius is given as 0.025. Hence, the theta value is coming out as 0.0175 radian. And by converting this radian value into degree, we have to multiply 180 divided by pi. Hence, we got the theta value in terms of degree as 1 degree. Okay. So now we have to solve another problem regarding torsion equation. So here the question is, a shaft is made from tube. The ratio of the inside diameter to the outside diameter is 0.6. That is, the capital D divided by small d is equal to 0.6. The material must not experience a shear stress greater than 500 kPa, that is kilopascal. The shaft must transmit 1.5 megawatt of mechanical power at 1500 revolution per minute, that is RPM. Calculate the shaft diameters. That means here you can imagine that the shaft is hollow type because inside diameter and outside diameter is provided. Hence you have to determine the diameters. That means we have to calculate the diameter of the outer circular shaft and inner circular shaft. But only in the question it is mentioned the ratio between inside diameter and outside diameter as 0.6. So first of all, what are the data given? First of all, we have to write. So power is given as 1.5 into 10 to the power 6 watts. That is, here 1.5 megawatt is given, and we have to convert this megawatt value in watt. So we have to multiply the 1.5 value into 10 to the power 6. After that, tau value is given as 500 kilopascal. So we know that 1 kilopascal is equal to 1000 pascal. So here we have to multiply 500 into 10 to the power 3 pascal. Then the revolution of the shaft is given as 1500 RPM, that is revolution per minute. So here 1500 revolution per minute is given. Then the ratio between inside diameter to outside diameter is given as 0.6. That is, the small d divided by capital D is equal to 0.6. Hence we can put small d is equal to 0.6 capital D. So this is all about our data given in the question. So now, by the relationship between torque and power, we know that power is equal to 2 pi nt divided by 60. Okay. So here we can put this value, and from this we can calculate the torque value by putting all these things. Hence, previously we convert the value of revolution in the terms of second. So here we put 1500 revolution per minute, and this minute we can convert it into second by putting 60. Hence we got the value of revolution in terms of revolution per second as 25. That is 1500 divided by 60 is equal to 25. So we can directly put here the value of revolution as 25. So torque is equal to P by 2 pi n. So P is given as 1.5 into 10 to the power 6, and 2 pi n is calculated here 25 revolution per second. So by putting all these things, we got the value of torque in terms of Newton meter as 9549.3 Newton meter. After that,